Right now, the future of artificial intelligence, of literally everything we do online, is running through one piece of hardware, an NVIDIA GPU. It's the engine of the trillions of dollars of AI boom, but there is a problem. This massive power-hungry, heat-generating machine requires a lot of energy. We're running out of power and we're demanding too much. We need a new kind of computing, and now, out of Wuxi, China, a university-affiliated lab called ChipX has just announced a new chip that they claim is 1,000 times faster at AI workloads than the best NVIDIA has to offer. Think about that number, 1,000. Here's the interesting thing. The future of computing might not be electrical, but it might be optical. Let's talk about a photonic quantum chip and the global race to stop the AI power crisis. To understand why a 1000x speed up matters, you have to understand what kind of nightmare the modern computing is. Every app, every search, every AI chat is done with electronics, with bits of information being pushed around by electrons, and it creates a huge amount of heat and requires a colossal amount of energy to do anything complicated. The energy required by data centers is becoming sky high thanks to AI. Our current processors are running out of steam. This is a big problem. To solve problems like simulating complex molecules or managing global finance networks or training a billion parameter AI model, the classical electronic computer simply cannot keep up with the complexity. It's mathematically impossible within a reasonable time frame. We need a fundamental shift. We need quantum. Quantum computing is the future. But for years, it's been a nightmare of complexity. The most famous systems, the ones from companies like IBM, requires massive, complex quantum chandeliers, cooled to near absolute zero, colder than the deep space. That's not scalable. It's not industrial grade. ChipX in China claims to have fixed that problem, and their key is light. They didn't use electrons, they used photons, particles of light, as their qubits. Here's the crazy part. A quantum bit or qubit doesn't have to be just 1 or 0. Thanks to a principle called superposition, the photon can be both 1 and 0 simultaneously, and when you link two of them together in a spooky way called entanglement, they can process an exponentially larger amount of information. The power of this computer doubles with every new qubit instead of just growing linearly like a classic chip. The ChipX design is a photonic quantum chip that packs over 1,000 optical components into a small 6-inch silicon wafer, and because it uses light instead of electricity for data processing, it has 3 massive advantages. First, because light is naturally resistant to thermal noise, these photonic systems can operate at or near room temperature. No giant multi-million-dollar freezer needed. Second, photons travel incredibly efficiently and faster than electricity. And third, it generates no heat. This completely changed the economics of the data center. This design is allegedly the world's first scalable industrial-grade quantum chip, and it's already being used in industries like aerospace, biomedicine, and finance. Systems with these chips can be deployed in just 2 weeks instead of the 6 months it takes for traditional setups, and hypothetically, they can be scaled up to support 1 million qubits. So if China has a chip 1,000 times faster than NVIDIA, game over, isn't it? Well, not so fast. Every technological revolution has its Achilles heel, and for the ChipX chip, it's not the physics, it's the factory. The materials involved, like thin film lithium niobate, are incredibly delicate. Right now, the pilot production line can only crank up about 12,000 wafers per year, and each wafer yields roughly 350 chips. That is a low production volume. NVIDIA is making chips by the millions. This Chinese breakthrough is incredible, but it's not yet a supply chain revolution. This scarcity is the new front line of the global tech war. China is aggressively competing with Europe and the United States to develop the photonic chips. Western firms like California-based PSI Quantum and the Dutch company Smart Photonics are pouring cash into their own silicon photonics and indium phosphide chip lines. They are adapting their massive existing semiconductor fabs to this new light-speed technology. So the battle isn't over who can invent the future, it's over who can manufacture it, who can take this complex, delicate science and make it cheaply, reliably, and at a scale that can actually power the global AI boom. The 1,000 times faster claim might be true, but the revolution isn't a single chip. It's a new kind of engineering, a new global manufacturing built on light. This Chinese breakthrough is a massive, tangible signal that the electronic age is slowly but surely coming to an end. The only question now is, who owns the future when the light finally turns on? It looks like it's going to be made in China. Disagree? Comment below. Thanks for watching. If you haven't subscribed yet, do it now. Till next time, bye.